Good morning to everyone. Today I am going to discuss about principles of programming language. First unit, preliminary concepts. First, introduction of principles of programming language. Why we need programming language and reasons why we learn programming language. Introduction. The principles of programming language comes from concatenating of principal plus programming languages. By defining principles, it is the fundamental norms, values, rules, and regulations that are used to represent what is desirable and positive for any job or task. It is the helpful in determining the rightfulness or wrongfulness of any state's task. Informal principles are very basic than policy and objectives and are meant to govern both. While programming languages relates to formal construction of languages by expert programmers that leads to communicating high-level instruction, example human instructions to a machine. Machine means general computer or a specific computer. Example application based computers. A programming language can be used to create application programs, scripts, or other sets of instructions to control the behavior of a machine or to express procedural steps called algorithms. Principles of programming language is a set of rules and norms governed to communicate instructions. Instructions means high level instructions or assembly level instruction to a machine or particularly a computer. Reasons for studying programming languages. The following is what we believe to be a compelling list of potential benefits of studying concepts of programming languages. Reasons for studying programming languages. First one, increased capacity to express ideas. People can easily express their ideas clearly in any language only when they have clear understanding of the natural language. Similarly, if programmers want to simulate the futures of languages in another language, they should have some ideas regarding the concepts in other languages as well as. Programmers in the process of developing software are similarly constrained. The language in which they develop software places limits on the kinds of control structures, data structures, and abstractions they can use. Thus, the forms of algorithms they can construct are likewise limited. Programmers can increase the range of their software development through development thought processes by learning new language constructs. For example, a C programmer who had learned the structure and use of associative arrays in Perl might design structures that simulate associative arrays in that language. Second one, improved background for choosing appropriate languages. Many professional programmers have had little formal education in computer science. Rather, they have developed their programming skills independently or through in house training programs. Such training programs often limit instruction to one or two languages that are directly relevant to the current projects of a organization. Many programmers, when given a choice of languages for a new project, continue to use the language with which they are most familiar, even if it is poorly suited to the project. If these programmers were familiar with a wider range of languages, they would be better able to choose the language that includes the features that best address the characteristics of the problem at hand. Next one, increased ability to learn new language. In software development, continuous learning is essential. The process of learning a new programming language can be lengthy and difficult, especially for someone who is comfortable with only two or more languages. Once a true understanding of the fundamental concepts of language is acquired, it becomes far easier to see how these concepts are incorporated into the design of the language being learned. Finally, it is essential that practicing programmers know the vocabulary and fundamental concepts of programming languages so they can read and understand programming language descriptions and evaluations, as well as promotional literature for languages and compilers. These are the sources of information needed in order to choose and learn a language. Next one, better understanding the significance of implementation. An understanding of implementation issues lead to an understanding of why languages are designed the way they are. This knowledge in turn leads to the ability to use a language more intelligently as it was designed to use. We can become better programmers by understanding the choices among programming language constructs and consequences of those choices. For example, programmers who know little about the complexity of the implementation of subprogram calls often do not realize that a small subprograms that is frequently called can be a highly inefficient design choice. Next one, better use of languages that are already known. Many contemporary programming languages are large and complex. Accordingly, it is uncommon for a programmer to be familiar with and use all of the features of a language uses. The concept of programming languages, programmers can learn about previously unknown and unused parts of the languages they already use and begin to use those features. Overall advancement of computing. There is a global view of computing that can justify the study of programming language concepts. For example, many people believe it would have been better if ALGOL ALGOL 60 had displaced photon in the early 1960s because it was more elegant and had much better control statements than photon. That did not due partly to the programmers and software development managers of that time, many of who did not clearly understand the conceptual design of ALGOL 60. If those who choose languages were better informed, perhaps languages would eventually squeeze out poorer ones. These 6 points are reasons for studying, why we use programming language, of reasons studying programming languages.